In this section, we're going to discuss about numeric errors in loops. A floating point number is represented by encoding the mantissa and the exponent as integers. Since there's only a set number of bits available, each floating point number is usually an approximation of the number it should represent. A double has about 15 digits of precision. If the number being represented needs more, then obviously it has to be rounded to fit. Loops often are used to manipulate floating point numbers in their body. But this imprecision of floating point numbers can have some very negative effects. For example, summing floating point numbers should be done in a precise order. If at all possible, the smallest to the largest should be added in that order. Not doing so will cause a type of error such that it appears such that smaller numbers may not affect the sum. If a sum is being computed and early in that process very large numbers are added, then very small numbers are added. If those small numbers don't fall within the range of precision that those large numbers have, that is, they're more than 15 digits out from the size of the large ones, then because of rounding, those small numbers will never be added. They just don't represent a large enough value to affect the sum. This is why we would choose to do smallest to largest, because the cumulative effect of adding those small ones may add up to a number large enough to affect the overall sum after the large numbers have been added. But if the small ones are added later, they probably never will affect the sum at all, even though they should have. So be aware that floating point numbers in particular in loops can cause strange results.